Hey, yo, what's up? So today I'm gonna do this problem. We're gonna read this out loud. I think that's very crucial. Control V is boy. Consider the system of components connected as in the accompanying picture. Components 1 and 2 are connected in parallel so that subsystem works if and only if either 1 or 2 works. What that means is as long as one of this works, then this whole thing will work in the top set. In this case, we're going to call this subset A. What I want is a bigger size brush. Beautiful. And we're going to call this subset B. What this is saying is this is a series subset, and it only works if both of these works. So this is contingent on this, 3 is contingent on 4, 4 is contingent on 3. But notice that this one, this subset B, is parallel to the subset A also, meaning that subset A is the exact same as subset B, but it's the exact same logic that we're going to use for the whole thing. So it's asking for the probability of A or B is working. So we have a formula for that actually. This is actually the addition rule. Therefore we get probability of A plus, I need bigger size, yeah, so it looks better, plus probability of B minus the probability of A cap B. So the probability of everything happening here is a probability of A plus the probability of B minus the probability of A and B. So what the hell does that mean? So the probability of this system working plus the probability of this system working, and you subtract that by the probability of both of them working, gives you the union set between A and B. And we're just gonna do that problem right now. Let's get into it. First part of starting, we need to find the probability of A and the probability of B. This one is easy. B is probably going to be your easiest one because this one is contingent on this one. Therefore, B of 1 is, because B of 1 and B of 2 have to work. Therefore, you can just multiply this by 0.9. Keep in mind that each one of these components is 0.9 because of that thing right there. So we already found probability of B, which is 0.9 times 0.9. Mother shitter. Alright. So now we have to find the probability of A. We have to bring this down also. So the probability of A, we have to use the addition rule again, because this is subset A1. Looks like a child with polio, but you know. And this is A subset 2. Oh man, his cousin came along. So to find the probability of that, we use the addition rule again, which would be the probability of A is equal to the probability of A1 plus probability of A2 minus probability of A1 and A2. So let's plug and chug. We know that each one of these is 0.9. So what we can do, 0.9 plus 0.9. And we also have to subtract it by the cap. And what you do by that is... the cap is just, 0.9 times 0.9. It's just A1 times A2. So in that case, we get 0.9 squared. So let's do that calculation. You get 1.8 right here. Minus 0.9 squared is 0.81. So that means the probability of A is equal to, I believe, 0.99. 0.99, yep. So now we have to find, so we find B, because since B1 is contingent on B2, we just multiply those together, leaving us with 0.81. Therefore, probability of B is also, is actually 0.81. And now, no, I really hope this works. Oh, darn it. I lost everyone, didn't I? Actually, no, I'm right. So that's that. This is probability of A. So the probability of A cap B. So we established that probability of A is 0.99. We established the probability of B is 0.81. So let's bring those together. So 0.99 plus 0.81 that gives us 1.8 again, and we have to subtract it by A cap B, and A cap B is 0.99 times 0.81. So 0.99 0.81 that's equal to 0.8019. And remember, it's subtracting. 1.8 minus 0.8019. And then you get that tall order of 0.9981. I know this did not make sense at all. I'll try to remake it. Just literally just ask me and I'll remake it on the spot. But a lot of people have the quiz right now, so...